This lecture is going to give you an introduction to reproductive physiology of domestic animals, specifically using the Singer textbook. So, it's always important when we start talking about one of these major disciplines within the livestock industries that we spend some time talking about why it is important. So, reproduction is crucial to the livestock industry as well as to conservation efforts in other wild species, conservation of our species, etc., because it's all about how we propagate and preserve a species. And so it becomes really important to keep these things in mind as we are navigating um, production calendars and goals of an operation on the livestock side. So, some things to keep in mind. First and foremost, reproduction is cyclic, meaning that it happens in a cycle. Okay, so we're just going to jump in right here in the bottom left hand corner. And so, if a dam or a female gives birth to an individual, then that individual is going to grow. It's going to go through physiological changes, specifically puberty on the reproductive side. And once that individual becomes pubertal, it's then going to have the ability to be exposed to events that are going to lead to copulation. And so, copulation is where spermatozoa will enter the female tract and will start traveling down that track to find its site to find the site of fertilization. And so those events that lead to copulation are going to also give that individual an improved chance of pregnancy occurring. Okay, so once the female goes through estrus and is exposed to a male, that and that spermatozoa is going to be in the track at the exact right time, then fertilization has the opportunity to take place. And here we have a choice point. And so if fertilization is successful, then that embryo will then require nutrients to grow. So that conceptus is going to turn into an embryo and then into a fetus. And that fetus is going to grow throughout the gestation cycle. And once that embryo or fetus goes through the differentiation process where organs will develop into their specific goals, like liver and brain and lungs, etc., then that individual is going to grow in gestation until that dam gives birth. However, if we go back to that choice point where fertilization had the opportunity to take place and it failed, then that female is going to go back into the estrous cycle and her body is going to prepare for pregnancy again. And so this decision between a failed fertilization or a failed chance of getting pregnant and exposing that female to events that can lead to copulation, this is our biggest area to make management decisions and genetic progress. And so we're going to talk about different aspects of this entire cycle throughout this class. But one thing I want you to keep in mind is that this whole process is cyclic. Okay, so it occurs in a cycle. So, as we start to dive into reproductive physiology as a discipline, it's important to have some historical basis. Okay, so the discipline of reproduction has been studied since about 350 BC. It actually started with Aristotle, which we'll talk about in just a second. But most of our knowledge and most of the technology has only been generated within the last 100 years. So Aristotle really started the philosophical debates around reproduction during his time. And so his first book was actually on reproductive physiology. It was The Generation of Animals. And in this book, he actually cited that his thoughts were that the fetus arose from menstrual blood, and that the reproductive process was initiated by seminal fluid. But keep in mind, Aristotle was just a philosopher, so he sat around and thought on concepts based on the observations that he saw, but he never did any research. So it wasn't until about the 16th century that we really started seeing the first true reproductive scientists emerge. So first with Fallopius in 1562, who described what oviducts were, and the fallopian tubes are actually named in his honor. Cotier, in about 10 years later, discovered what the corpus luteum on the what is now considered the ovary. And then de Graaf, in about 100 years later, discovered the Graafian follicle, so the other major structure on the ovary. And then finally, a few years later, Van Leeuwenhoek actually used the microscope to discover what sperm were. And this led to the thought process that the animalcules were actually fully formed individuals, and the females were actually incubated or did the incubation process. And so after that, those were kind of the very first, I guess, of what we call the somewhat modern discoveries about reproductive physiology as a discipline. But modern reproductive physiology in the last 100 years has really led to technologies such as artificial insemination, detection of pregnancy using biochemicals, so blood and hormones. The cloning technology has been a huge contributor in reproductive physiology in the last 20 years. Contraception, so prevention of pregnancy, and we see that quite often in human species. Embryo culture and transfer, endocrinology, which is the study of hormone secretion, and estrous synchronization, which is really big in our livestock industries. The technology associated with frozen semen, in vitro fertilization, which has been instrumental in the livestock industries, but more so in human reproduction. And then finally, more recently, sex selection. So sex semen, and then even sex selected semen and embryos. And so these are a lot of really cool modern reproductive technologies. So some things to keep in mind as we start looking at reproductive physiology in the context of livestock species. If there was a 3% improvement in reproduction across the entire world in all livestock species, in a given year, that would result in 1 million more calves, 3.2 million more pigs, and 3.7 more gallons of milk per year. And so these are really important numbers, especially as we are in the crux of an increasing population. So you guys have probably heard the statistics thrown around that by 2050 there's going to be 9.8 billion people on Earth. So these numbers become really relevant quickly to make sure that we have enough resources to feed that growing population. And so just a little bit of context here, that if we work on improving reproduction and we only make a 1% improvement in reproduction, we're still making significant progress. So these are just a few of the statistics that I was talking about beforehand. So again, by 2050, we're going to have 9.8 billion people in the year or on the Earth, and so it's kind of interesting. So, in the time it takes people to listen to the sentence or read the sentence, 24 people are going to be added to the Earth's population. If we look at that on an hour timeline, it's going to be 12,000 people. And within the course of a day, there's 288,000 individuals that contribute to the world population growth. And so, one of the major areas of challenge for reproductive physiologists is this struggle between decreasing the rate of the human population growth and increasing reproductive efficiency in food animals. Okay, and so both of these things are absolutely up for controversy. Not everybody agrees on them, but both of these philosophies actually are only going to come to fruition if the public is educated properly. So just keep these big concepts in mind as we work through the semester. And then finally, if you guys find yourself like me when I took this class, just absolutely mesmerized and excited by reproductive physiology in livestock, please realize that there are lots of opportunities available to you from a career standpoint. So you can always go into animal reproduction and consulting. If you are interested in the clinical side of things, you can always do lots of reproductive work as a veterinarian, a medical doctor, or a technician. There's always opportunities to educate the public about reproductive physiology and develop new technology that will transfer from the research industries into the general reproductive industries. Research and development is a huge area of reprophys right now, as is pharmaceutical manufacturing research and development. Okay, and so there's lots and lots of opportunities to be involved with and experience reproductive physiology on a daily basis in a career. So I hope that you are as excited about this class as I am. I really enjoy reproductive physiology. I got into it when I took a embryo transfer class at the community college in Susanville. And from there, I transferred to Chico State and really became involved in reproductive physiology during my 490 project while taking this class, and then as herdsman at the beef unit when I was a student. And so this really set the course for my graduate work. I was very interested in reproductive physiology, and so my master's degree and my PhD both have aspects of reproductive physiology, more with a genetic basis, but definitely around reproductive cycles. And so I hope that you guys really enjoy this class, and we're just going to make our way through the semester and learn this discipline from the ground up.